Hello class. So this is chapter 12 and 13. We're going to be talking about regression. So I'm going to post this on Blackboard, but this is a video so I can take you through how to do a regression. Now there's multiple ones. We're going to do a single variable, which is what I have here. If you click on problem 2, down here, we have a different one. Problem 3, we have a multi-variable with a binary variable. And then what if it's not linear? So that's the other problem I'm going to show you. Okay, so here we go. Okay, so I've collected this data on Ace paint sales, and then I have the price of Ace paint beside it. Okay, so let's go to data, and for those of you who haven't added the regression packet, you need to contact me and I can walk you through that. But if you click on data at the top and you click on data analysis, you have to scroll down, find regression, and hit OK. Okay, so then the screen comes up. So your Y variable is what you're trying to predict. So in this case, we're trying to predict Ace sales. So I'm going to come down. I'm going to capture them all. Okay, and then my X variable, I only have one. This is what I'm using to try to predict what causes sale. So I'm going to go with the price of Ace paint. So this is what I have. We'll go down. Okay. Now I need to click labels because I've included labels so that way it doesn't read the first cell as something else. And then I'm going to have an output range. Now be careful. Whenever you click output range, it automatically uses this right here. It automatically selects this. You need to come down here and actually click that. And let's just click here to have it send it to. I'm going to hit OK. Okay, so then what you have here is your summary output or your regression results. So this is what it's going to tell you. Okay, so the first thing I need to look at is my R square. Okay, so my R square tells me how best this data fits my cells. So in this case, I have an R squared of about 8%, meaning that the price of the Ace paint is predicting the Ace paint cells about 8%. Okay, so not incredibly high, but it depends on what kind of class you're in. It depends on what kind of discipline you're studying. For a social science, which is what econ is, a lot of times 8% is great because you're able to come up with consumer behavior, able to predict consumer behavior by 8%. If you're in an actual science, like a hard science, not necessarily soft science, a hard science, like if you're in chemistry or something like that, 8% would not be all that great. You would not be published. You would not continue. You would do something else. So it just depends. So whatever it is, it is. So on your test or on your projects that you're doing in a couple of weeks, whatever your R squared is, it is what it is. Okay, just leave it alone. Okay. You also need to talk to me about your p-value. Now, your p-value for the price, the p-value tells you if the variable is significant or insignificant. So in this case, if the p-value is higher than 0.05, it is insignificant. So in this case, it is significant because you have it lower than 0.05. Okay, so these are two things you need to look at, your R square and then your p-value. Okay, now let's look at the next one. Let's look at problem 2. Now what if I wanted, okay, now since this only predicted 8%, what if I wanted to find another variable? Okay, so in this case I have the number of paint bays. Okay, so at the shop they have all these sales and this is how many bays they have at the corresponding time. So I want to say, I wonder if they're related. So I go to data, then I click on data analysis. Regression is already selected because I just did it. Now it's going to naturally pick the same one as you had before. It's going to know, it's going to be intuitive. So this time you can kind of just hit OK and it'll output it right beside it. Now, okay, what do I have? Okay, so this is a little better. Okay, this is a 60% R square. So if I asked you which was a better indicator of sales, would it be bays or the price of the paint, you would respond that it would be the number of bays because it gives you a higher R square. Now I'm going to go down here to my p-value. Now a lot of times students get confused right here because they say, well, this is higher than 0.05. No, it isn't. Look at this e to the negative 12. That means there's 12 zeros outside going this way. Do you understand? Okay, so this means this is a very significant variable. So We're getting closer. Okay, now, problem 3. Okay, what if I wanted to put them all together? So what we've done before is just a single variable regression. Now we're about to do a multivariable. Okay, now, now I'm combining the price of the paint, the number of bays, and then I'm going to select whether or not they did other services. Now this is what we call a binary variable. So this is almost a categorical, if you could remember back from the beginning in chapter 1 where we had to list if it was numerical or categorical. This would be categorical. So it's kind of like yes or no answers, or male or female, or different, categories. Now, whenever you do a binary variable, you need to call me if you're doing this for your project, or send me an email so we can discuss it, because a lot of times students think a binary variable can go up from 1, 2, 3, 4, 5, 6, 7, 8. That's not true. If you have 8 different colors of sweaters and you're trying to determine whether or not the colors of those sweaters have to do with the number of cells of those sweaters, you cannot go like 1 being pink and like 8 being purple. Because what's going to happen is Excel is going to read the 8 for purple is 8 times greater than pink. Do you understand? So whenever you're doing binary, it has to be like, 1 and 0 would be like a standard, yes or no, or 2 variable binary. If you had up to 8, we'd have to work that out, but it would be something like 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0. You see what I'm saying? You have to shift it so it tells it all of this binary, but they're all distinct, so you can tell how many purple sweaters you sold and how many yellow sweaters you sold, how many orange. Do you see what I'm saying? Okay, so if I want to do a multivariable regression, I'm going to come up here to data analysis. Regression is already selected. Okay, now my Y range is correct. I'm trying to predict ACE cells. Okay, but my output range for X has changed. Okay, so I'm going to do the price, the number of bays, and whether or not they offer other services. So I'm going to select all this, come all the way down. Okay, good to go. It remembers that there's labels. I'll click in my output range. Let's change that a bit. Let's move it over here. Okay, so then I'm going to scroll over a bit so we can see it. Okay, now we have an R-square of 0.88, which is good. We've come up. Okay, now we have to come down here and we have to look at our p-values. Now, that one's good to go. It's less than 0.05. That one's good to go. And that one's good to go. So they're all significant. Now, there could be a case where your p-values, one of them is greater than 0.05. And what I do at that time is I discard that one and I run it again to see how it affects my R-square. Now, every time that you discard a variable, it's going to give you a little bit lower of an R-square. But you want, at the end of the day, you want all of your variables to be significant. If, for example, if you're doing your projects and you have like 8 X's, right-hand variables, then you're gonna run your regression and you're gonna see how many of them are significant. Now, you toss out, the way I do it is you toss out the worst one first. So the highest p-value is the one that you would toss out first, and then you would rerun it. Because let's say you have 3 that you consider to be insignificant, you don't throw out 3 all at one time. You're going to toss out 1, and then you're going to rerun it, because normally it's going to affect the p-values of the other ones that you have listed. Okay, so let's look at problem 4. Okay, what if it's not linear? So a lot of times we assume that the data that we have is linear, but it could be that it's multiplicative. So this is a multiplicative regression that we're about to do. Now, the way you do this is almost the exact same. It just has one different step. Now, if you're doing a nonlinear regression, you cannot use a binary variable, because what you have to do is you have to take the ln of everything. Okay, ln of price. Okay, the natural log ln of my bays. Okay, ln of cars. And then ln of competitor. Okay, so what I'm going to do, I'm going to come over here and I'm going to hit enter ln. Okay. Now the great thing about Excel, if you're doing this, years ago, this would not be possible. But the great thing about Excel is that you can bring this all the way down. I'm just going to take the ln of every single one of them. Okay. Whoa, look at that. It's like warp speed. Okay, so I'm going to like underline this. Okay, now we have to run our regression using our ln. And a lot of times we do a multiplicative regression with linear data, or because we're not sure. We're not sure if it's linear or we're not sure if it's multiplicative. And so the thing that's going to tell us is which R square is higher. It's going to tell us more if it's multiplicative or if it's linear. Okay, so I'm going to go up here to data. We're going to run a data analysis regression. Okay, now I have to change everything because it's going to select the other ones. Okay, so let me put it over here so you can see. So my Y is going to be my sales. Okay, and then my X is going to be all these others. Make sure you hit them all. Okay, I have labels. I want to do a new worksheet. Good to go. Okay, so this is where it puts it. It's getting crowded on the other one. Okay, now let's look at this. My R squared is 0.64. So let's look back to the other one. We had a 0.88 R squared, so we're a little lower. Okay, now let's look at my p-values. Whoa, that one's no good. Okay, that one's okay. That one's no good. And that was no good. So if you just had this question on your test where it was, you know, do you think that this data is mostly linear or do you think it's multiplicative? In this case, you would say I think it's more linear because all my variables were significant under linear and only one of them is significant under the multiplicative. Now in other courses you're going to use this kind of data and you're going to write equations for your lines, and so you're going to know, or curves, so you're going to know how to do that in other courses. But I'll just give you a little bit of a warning. Your intercept right here, you can't just use that as your constant to begin with. You'd actually have to take the e to the of this to get your actual number at the beginning, because remember this is the natural log. So reverse that, I have to take e caret to that number. But you'll do that in other courses, so I just wanted to get you to make sure you have the basics in this stats class. So let me know if there's any questions on this. I'm going to put this data out there so you can play with it to see if you're getting close to the same thing, or if you're having questions, or you know, you have concerns. Now if you're doing this, I'm going to move this because this aggravates me, they put it the other one. So if you're doing a regression in your projects and you're having trouble, or you want to know, like, should I do the ln, should I do a multiplicative, or should I do linear, let me know and we can work that out. So have a great week. Let me know if there's any questions. Thanks.